Welcome, ladies and gentlemen. So what I'd like to do is show you how to apply operations when they involve the dot product. So we already covered kind of the dot product, basically just finding the dot product between two vectors. But what about if we add some additional operations, multiplying by a separate vector or a multiple or a scalar or adding before we do that. So just a kind of a little bit of extension of applying the dot product. So if you remember, just want to make sure I got everything working. Okay. So I have my vector u, I have my vector v, and then as well as I went up with the formula for the dot product, just remember. But remember, the dot product produces a scalar, does not produce a vector. Very important, a lot of students sometimes forget. And remember that dot represents the dot product, not multiplication. There's your formula. Component 1 times component 2 plus component 2 times times component 2. Okay, so what happens if I do the dot product of a vector by itself? Well, let's go and take a look. So basically, I have my vector v, which is negative 3i. Oops, sorry. Let's just write this. Let's write this in components. Negative 3, negative 2. Now let's write below. Dot negative 3, negative 2. So basically, that's going to be v1, v2, and this is going to be v1, v2 again. So we don't really have a u, but we can still kind of do the same thing. So it's going to be negative 3 times negative 3 plus negative 2 times negative 2. So negative 3 times negative 3 is going to be a positive 9, plus negative 2 times negative 2 is a positive 4. Therefore, the product v of the dot product of itself is going to leave us with 13. Now, in this case, we have 3 times u dot product, 3u dot product with v. So the first thing I'm going to want to do is rewrite this in component form. And basically what I'm going to do is write it in component form. So then I will apply the scalar, though, first to apply that operation. And then v, which is negative 3, comma negative 2. So I'm going to want to apply the scalar first. So that's going to give me 12. Negative 15 dot negative 3, negative 2. Now I can label them as, so this would be my u1, u2, v1, v2. And then basically I just go ahead and apply them into the operation. So the dot product is going to be 12 times negative 3 plus, actually, I guess, you know what, let's just use parentheses maybe. Maybe that'll make more sense. Plus negative 15 times negative 2. So 12 times negative 3 is going to give us a 24, negative 36. And that's going to be plus negative 15 times negative 2 is now going to be a positive 30. So that's going to leave us with a negative 6. Now in this case, I have a scalar, but I have the dot product inside of those parentheses first. So I need to apply the dot product first. So I'll write them out again as my component form for negative 5. Dot product with my v, which is negative 3, negative 2. Okay, so now I'm going to apply the dot product. Again, you can label them as your u1, u2, v1, and v2. And it really doesn't matter what's u, what's v, what's w, what's x. Just make sure that you're multiplying the first components times each other and then adding them to the product of the second components. So 4 times negative 3 is going to be a negative 12. It's not a vector, don't forget. Plus negative 5 times negative 2 is going to be a positive 10. So that's going to be 5 times negative 2, which equals a negative 10. In the next example, I have the dot product, and now instead of multiplying it by a scalar or a scalar, I'm multiplying it by a vector. So again, we're just going to do the dot product of u times v first. So I'll just do 4, negative 5, dot v, negative 3, negative 2. And then multiply that by the vector v, negative 3, negative 2. OK, so by applying the dot product again of u dot v, I guess I probably already have done these, both u dot v. I guess it really doesn't matter here. That becomes a negative 12. That becomes a positive 10. Why am I writing vectors? It's not vectors. It's a scalar. Negative 3, negative 2. So that becomes a negative 2 times negative 3, negative 2. Now I distribute my scalar, and my final vector is going to be a positive 6 and a positive 4. Okay, and the next one here, I can basically do u plus v, and then I'm going to multiply that by my vector. So again, kind of the same thing, but instead of applying the dot product first, I'm going to add the two vectors. So in parentheses, I'm going to have u for negative 5 plus v, negative 3, negative 2, and then dot v, which is negative 3, negative 2. Uh-oh, run out of space. Okay, so by adding these, let's see here. I'm now going to do 4 plus negative 3 is 1. Negative 5 plus negative 2 is negative 7. So I add those two vectors. And now I'm going to apply the dot product with the vector negative 3, negative 2. So to speed this up a little bit, I'm just going to multiply my first two terms. So 1 times negative 3 is negative 3, and then add that to the product of my second components. Negative 7 times negative 2 is a positive 14. Negative 3 plus 14 is going to give me a positive 11. All right, last example. We're going to do u dot v and v dot u. Now, one thing I want you to understand is if you notice, when we did u dot v, where did we do u dot v? We got negative 2. When we did, oh, I didn't do a v dot u, did I? Dang it. When we did a v dot u, what we'll notice is, what I want you to understand is it doesn't really matter. Well, I guess I might as well just show you, right? So let's go ahead and break this up. U, which is 4, negative 5. It's not going to matter. You're going to get the exact same answer, what I'm trying to show you. But since I didn't do it, I guess I might as well show you how they're both the same. And then u, 4, comma, negative 5. OK, by applying the dot product, again, we're going to multiply the first two terms, which is going to give me a negative 12 plus 10. And then I'm going to add that to the dot product over here, which is negative 12 plus 10. And here what you get is a negative 2 plus negative 2. So the purpose of this is to let you know that it doesn't matter the order. It doesn't matter if I do u dot v or v dot u. It's not like subtraction where order matters. You're going to get negative 4. So there you go, ladies and gentlemen. That is how you apply operations with vectors when you have the dot product. Thanks.